We're live. All right, so that's what we got. They tell us that AFB is 50, so there's AFB, he labeled it. And he also told us that EFD is 50, so he labeled that. Cool. They tell us that BFD is a line and EFC is a line. So when they ask about BFC and DFE, we're talking about BFC, that's this angle here, and DFE down below. What kind of angles are those? Mr. Eads?
What?
What kind of angles are those?
Scissors.
Scissor theorem, which are what kind of angles?
Vertical.
Vertical, very good. So that means they're both going to be the same. Vertical angles theorem says that those measures should be the same, so they're both going to be 50 and vertical. BFA and DFE, BFA and DFE. So we're talking about these two guys. Well, they gave us that they're both 50, so that's free, right? Are they vertical angles, though?
Yeah.
They're equal, but they're not vertical, right? Neither. They're just angles that happen to match up, right? Sometimes that happens. BFC and CFD. BFC is the top part. CFD is the side part. So we have these two. Vertical, linear pair, what are they? Linear pair, right? They're on the same line together. There's the line, right? Two angles on the same line, that's a linear pair. Pair means two, linear means line. We are on number 3. Oh yeah, by the way, who needs pens?
Nope. Never. I do.
Maddie, do you need one? I love my job. All right, number 3, linear. So they add up to 180, right? They're on a line. Lines are 180 degrees, straight angle. So if that one's 130, the other one, actually, we knew the other one was 50 from earlier, right? So that must be 130 by subtraction. So far, so good, Mr. McCartney. AFE and AFC, which are conferences, I believe, in football. AFE, AFC. That's this big angle right here. Check it out. They're a linear pair. They're on the same line. We have this angle and this angle. There's 2 of them on the same line. Don't be confused because there's 3 individual cuts, right? I'm talking about this angle here, which is one idea, and this angle there. That's 2, right? It's cut up into 2 angles here, but it's still one idea. So one angle plus another angle, that's a linear pair. We know this one right here was 50, and that's 50 as well. So that must be 100. So how much is left over here? If this is 100, how much is left over here?
100.
They don't add up to 200. What do they add up to? 180, right? This whole thing's 180. Mr. McCartney did not label it, but that's okay. I didn't ask him to. This is 50, right?
All right, but to my back.
What about the other one?
So 50, 50. This one right here.
80.
It's got to be 80, right? Because they should add up to 180, right? Huh?
The last 2 are wrong then.
That's cool. BFE says next. We're on number 5. BFE is this. Gentlemen, get funnier or shut up. Mr. Eads, quit while you're ahead.
What he did?
What'd he do?
Put his boot on my.
I don't see anything.
It was already dirty.
That's true. BFE is this angle right here. So first of all, what's the measure of BFE going to be?
You're an idiot.
Mr. Eads, what's the angle of BFE going to be?
Let me see.
130, right? Very good, Mr. McCartney. 80 plus 50 is 130. Now they want to know CFD, this angle right here. Well, that's also 130, so I would suspect they're vertical. They don't always have to be, right? We saw these 2 aren't vertical, but they're 50, right? These are both 130. They don't have to be, but they are. Imagine if I took out that A part, right? I've got an angle here and an angle there, both comprised of straight lines, right? Here's this line and here's this line. That's the scissor theorem right there, right? 130, 130. Those are vertical angles. AFE. AFE is this guy. BFC. BFC is this guy. Both are 50. Or I'm sorry, not both are 50. One's 50, one's 80. Are they vertical?
No, they're linear.
Are they a linear pair?
Yeah.
They're both on the same line, but do they add up to 180? Those 2 angles, this one and this one? Nope. So they can't be a linear pair, right? Linear pairs always add up to 180. Doesn't work. So they're just different angles. That's it.
Neither.
Neither. Sorry, Mr. McCartney. AFE is also wrong. All right. Number 7, it says AFE, DFC, and BFC. AFE is this guy. AFE, DFC, and BFC. These three. They got anything in common? The three of them? These two have something in common, right? They're a linear pair. But what about all three of them? Nah, they're just angles. That's 80, that's 50, that's 130. Turn the page. Did this all together. So let's see how many points the backside should be. 1, 2, 3, 4, 5, 6, 7 on the backside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 on the front side. So 19 on the front. How much did I say on the back? Oh, I missed one. 1, 2, 3, 4, 5, 6, 7, 8. 8 on the back. 19 plus 8, 27. If you're going to throw it, don't miss.
I wasn't trying to hit you. So I didn't really miss.
27. If you like your grade, turn it in. If you don't like your grade,
What'd I get?
only a -2, Mr. McCartney.
Thank you.
25 out of 27. Commendable. I don't know what that is as a percentage off the top of my head, but I bet it's worth turning in and getting the grade now. Unless you want to correct them and get 100%.
Yeah, I'll do that.
Yes, sir, Alex.
A vertical?
5, 6, and 7.
That's not me, that's him.
Mr. McCartney, would you mind passing back your sheet to Alex so we can see what the right answers are for 5, 6, 7, and 4?
I don't do that.
He did miss some of those, but I think you can infer
Wait, it was neither, right? And then it was 130.
something like that, yeah.
You're a strange individual.
Yes, he is.
So weird.
You're the weird one.
Yes. He's just not in here. All right, have a seat, Mr. Eads. Would you like to change your seat? You sure? Because if you don't want Tucker putting his feet on you, and there's nothing I can do about that, I think we just have to move you. It's the only thing that makes sense. Tucker has to put his feet somewhere.
I gotta search my long legs.
That's right.
Long legs. You're short.
So check out this diagram. We got a lot of angles. We got 20 of them. Let's get out some colors. All right, so which ones do we know are going to be the same? Now, this is intimidating. When we have a hard problem, we usually replace it with an easier one and then go back from there. So watch this through the magic of television. So you see what I did there?
That's 117.
I removed one of the lines. I removed this one. That's all I did. Easier problem, right? Now, what do these symbols mean? They're not just arrowheads. What do they mean? Parallel, which means they are moving parallel to each other, means they never intersect. And this we would call what? What kind of a line is that? Starts with a T? Transversal. Very good, which sounds like a wrestling move. All right, so we have a transversal, cutting two parallel lines.
Have you ever wrestled before?
Yes, actually. My dad's a wrestling coach. I have a state ring.
That's not even close. Transversal.
It sounds like a wrestling move because there's a reversal.
Exactly. That's not.
You like to wrestle, Mr. Eads? You like wrestling?
Yeah,
No, my brother does.
wrestle.
Yeah, I think he does. All right, here we go. So, we have two parallel lines being cut by transversals. We know some special stuff here. Mr. Eads, your favorite theorem. You don't know much about it, but we learned some last week, okay? Scissor theorem. Which angles are vertical angles?
What?
4 and 7.
4 and 7 are. Thank you, Tucker.
3 and 8?
4 and 7 are congruent. 3 and 8 are also congruent. Now, is 3 congruent to 7?
No.
No, so I got to use a different color, right? 3 and 8.
4 and 14?
4 and 14 are congruent, but they're not because it's vertical, right? 14 and 15 are congruent. Now, they will be congruent to 4 and 7, so I'm going to use the same color. And 13 to 16 are congruent, right? And that's by vertical angles. How do I know that 4 and 14 are congruent, though?
They're on the same side.
They are. What do we call that? What kind of angles are those? Corresponding angles. Corresponding. Not that they're on the same side. Lots of angles are on the same side. Corresponding means top right, bottom left, bottom right, top left, right? They're always going to be congruent when we have two parallels being cut by a transversal. So we know that. Now let's go back to our original diagram. We know that 4 and 7 are congruent by vertical angles. We know that 14 and 15 are congruent by vertical angles. We know 4 and 14 are congruent by corresponding, right? Same thing with 7 and 15. Smell when I'm stepping in here? A little bit? Maybe not. 4 and 7 are scissor theorem. That's vertical angles theorem, right? Remember the top and bottom are always the same? Go back to the original, or the last one. See how we have like a scissor going on here? So top and bottom are going to be the same. That's vertical angles. Left and right are going to be the same. That's vertical angles. Again, here's the scissors. Not bad. Like that. These guys are the same. Those guys are the same. Same thing down here. Okay. How do we know 4 and 14 match up? Corresponding angles. See how they're both top right? They correspond. Small one of stepping in, Mr. Eads? Wonderful. What kind of angles are these guys? 7 and 14. What kind of angles? What kind of angles are those? Opposite or alternate, either way, yeah. Alternate interior, right? Opposite interior works too. They're on opposite sides, right? Alternate sides. It's all good. All good. All good. So they're on opposite sides, alternate sides, right? And they're in the interior. We have a theorem that says alternate interior angles are always congruent. Crisscross, bam. It's like playing checkers, doing that double jump. Those are all going to be congruent. That's right, you know about that.
Oh, yeah.
Checker champion over here. All right, so at least you play it a lot. So 3 and 8 are congruent by vertical, right? How do I know that 8 and 13 are congruent? Double jumps.
We should cover pumpkin.
What do I call those? Mr. Eads, quiet until you have better ideas. 8 and 16 are corresponding, you're right. And 3 and 13 are corresponding. That works. What's the other one I just talked about? Corinne brought it up. See how these guys are on the inside? Ignore this line, remember? We're ignoring that line for now. Alternate interior, alternate sides, interior angles. Nice job. Feeling okay?
Do we have homework today?
Oh, you betcha.
We have it right now.
No. Check this out. Same drawing, except I removed the other line. Smell what I'm stepping in? The magic of television. All I did was remove this line. Now we're here. Both are parallel. We have a transversal T cut in this, right? Ivy, which angles are congruent?
2 and 5.
Yep, how do you know that?
Because they're in the same spot, but like, you know what I'm saying? But they're like, I don't know how to explain it.
The vertical angles.
Yeah, they're vertical.
They're vertical angles.
Zach.
It's the scissor theorem, right?
Yeah.
Zach likes to say things, but he's not right very often. But sometimes he is. All right, and Alex. Oh, check this out. Check this out. So he's saying when we go back to here, look at 2 and 5 on here. Are those going to be congruent to 4 and 7? Not necessarily, right? We got a different transversal. So they're not going to be the same. Alex, well done. So I shouldn't be using the same colors. I should be using different colors. Now, could they be magically? Sure. But can we prove it? No. Looks like they're probably different, right? So I'm going to use something else. How about, well, let's not use red. We've already used pink. Let's try yellow. Let's try yellow.
That's
Not a fan of that, Mr. Eads? I'll have to use it more often. All right, so we have these two that are congruent by vertical angles. Ivy, keep going. What else do we know is congruent?
1 and 6.
1 and 6, also by vertical angles, right? They're across from each other. What's your favorite color, Ivy?
Yellow. But you
Oh man, what's your second favorite color?
blue.
Blue.
I need to start using that term.
Vertical angles. Mr. Eads, give us another set of angles that are congruent.
18 and 19 and
8.
17 and 20.
18 and 19, how do you know?
What?
18 and 19, how do you know?
Scissor theorem.
Very good, vertical angles. Now, how do I know, because I did the same color, and I'm not screwing up this time. How do I know that 2 and 18 are the same?
Corresponding.
Corresponding angles, very good. Both are in the top left, top left. Same thing with 5 and 19. Now, how do I know that? I know 2 and 18 are corresponding, right? How do I know 5 and 18 are going to match up too?
Corresponding.
They're not corresponding. He's bottom right.
Alternate interior.
Alternate interior. Inside, different sides. Boom.
Yeah, I paid attention.
Okay. Joey! What other angles are congruent? Give me angle numbers. We said 2 and 5 are. We said 18 and 19 are. We said 1 and 6 are. What else is congruent? 20 and 17. Now, how do we know those angles are congruent? Something. Vertical angle is very good, which is scissor theorem, so we know that. Now, Joey, we're going to go the extra mile here. How do I know 1 and 17 are congruent? I got these two from vertical, right? But how do I know these guys are congruent? It's the one everybody forgets. It's okay if it stumps you. I designed it that way. Starts with a C. Corresponding angles. Bottom left. Now, Joey, for the bonus buck, these two guys, 6 and 17. How do we know they match too? 6 and 17. Are they on the same side of the transversal or on different sides? Different sides. So that's alternate. Are they on the inside or the outside? Inside, so alternate interior, right? Bam. Tucker. Yes, you may.
Can you?
There they are.
I need to like go wash my face after it keeps touching me.
So back to our main diagram, we know these guys are congruent.
You know,
Mr. E, do you mind closing that door for me?
of course, I do mine.
Here we are. So we've done all but the middle. You ready? There we go. There it is. There's the middle. 9, 10, 11, 12. Maddie, the one and only today. Which angles are congruent and why? 9 and 12? And your favorite color is orange, so I'll use orange. We're running out of colors, Maddie. I'm sorry.
Yeah, I got 2 colors right here.
Wonderful. What else is congruent? Maddie. 11 and 10. Now, how do we know 11 and 10 are congruent? That's a bonus point.
Scissor theorem.
Scissor theorem, which is also officially named what? Stop it. Not horizontal. Vertical, exactly. So vertical angles theorem says these are congruent. Same thing here. That's it. Simple as that. We got 2 lines that intersect. We got vertical angles here and here. 9 and 11 are an example of what? Too soon? 9 and 11 are an example of what? 9 and 11.
9. Oh, I got it.
What if I do this? Does that help?
No.
What kind of angles are those? Miss McCartney, you were nailing it on the homework.
I got you.
Thank you.
I don't know.
Nah, it's just that.
There's 2 of them, and they're on a line.
Drenched, dude.
Let them in. Tucker,
Check my notes.
these ones right here are an example of what kind of angles? We got 2 angles on a line. Nope, not vertical. That's these guys.
Linear.
These 2 right here.
Top 2?
Yeah, top 2, 9 and 11. They're not congruent, and it is too soon. Linear what? There's 2 of them. He just came back from the bathroom. His mind's on other things. 9, 11 is a linear pair. Linear pair.
Can I tell you?
Pair meaning 2. Linear meaning line. Okay. What do they add up to? The degrees. Tucker, bonus question. What do these 2 add up to? If I were to add them up, how many degrees would that be? 180. Thank you very much. Mr. Eads, is it 200?
No.
It is not. But you do tend to think that. All right.
I need to like wash all my clothes.
Get a piece of paper out. Draw this. Go, 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 go.
Oh, cute. For $1. How about me? Huh? How about me? $10.
Gosh, Corinne, you made me mess up
Only
my
yours.
line segment.
Only yours.
Oh, that's never happened actually. Wait, where's the Ray?
What?
Or the line
Only
segment?
Bailey's.
I don't know. Whatever.
I don't think I'd be able to find
I want you to label these angle measures,
What you said?
and I want you to find all the rest. This is going to be your homework.
what?
Get your stick.
That's right. Tina, you fat lard.
Should probably crush them.
I was gonna wear my vote for Kansas shirt, but
It's always a good choice to wear your vote for Pedro's shirt.
What's that mean?
X plus 60.
So I'm supposed to find all these degrees.
Yep, every single measure. I'm only going to give you a couple more to work with, okay?
This is the homework?
This is the homework.
Whoa, 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 whoa.
I know.
Oh, ow.
I know.
Wait.
Okay.
Okay, I got it.
Sorry, that's not showing up very well. Let me use this color green. That's 70 degrees.
70, not 7.
Oh, I did.
Yeah.
Yeah, that's what you were saying.
Now, we talked about this briefly. See if you remember.
True, this one.
The other thing you need to know is that triangle angles always add up to 180 degrees. Okay? Triangles always add up to 180. So check it out. This is a triangle, right? So this angle, and that angle, whatever they are, should add up to 180, yeah? These three angles should always add up to 180.
They say no, but let's just read.
Always true for a triangle. So these three add up to 180. And I believe that is all you need to know to be able to solve this.
Alright.
Yes?
Find all the angles.
Hold on one second. I can't hear him. Alex, what's up? All three? No, these three added up would be 180. Yep. So those angles, the internal angles of a triangle, always add up to 180.
So we're just finding the angle measures.
Every single one, right? Now, if you've been paying attention, you know which ones are congruent already based on this. And if you haven't been paying attention, go check out the video, right? Get out of here, you nerds. Goodbye, Corinne. Go away faster, Alex. See you later.